Consider the continuous probability density function defined by y equals 0.5 on the interval where x ranges from negative 1.9 to 0.1. Here's a graph of the function, and we want to compute three probabilities. So the first thing I want to point out is that this function is, this problem is a little different than the last example we did, right? Here we are told that this is a probability density function. In the last example, we had to show that it was a probability density function, or we were asked if the function was a probability density function. Here we're told straight out this is a probability density function, which means the total area underneath this is going to be equal to 1. So let's go ahead and start with computing that first probability. We want the probability that x is less than negative 0.1. Okay? We want the probability that x is less than negative 0.1. Remember, the key here is that probability equals area. The probability we're looking for is the area of that region that's underneath the curve, okay, or underneath the function. In this case, our curve isn't very curvy, but mathematicians still call it a curve, okay? So I'm going to find that negative 0.1. That's going to be right around here. Okay, and we want the x's that are smaller than that negative 0.1. That's the region we're interested in. Okay, well, smaller values are to the left on that x-axis, so that's the part that I'm going to shade. I'm interested in this region right here, the part to the left of that negative 0.1. Okay. And let me go ahead and draw the edges, the left and right edges in here, so we could kind of get a feel for that. The left edge is at negative 1.9. The right edge is at 0.1. It tells me right here, right? So this guy's at negative 0.9, or I'm sorry, negative 1.9. And this guy's at positive 0.1. Okay? And so we could see, once we draw on those edges, it's a little easier to see, that this probability, we're interested in a region which is a rectangle, right? This probability is going to be equal to the area of this rectangle. Okay, probability equals area. So to find this probability, we just need to calculate the area of this shaded rectangle. Note this part over here we're not interested in. We're only interested in the part that's less than negative 0.1. Okay, so let's go ahead and find that. We know probability is equal to the area of the corresponding region underneath the probability density function. In this case, that shape is a rectangle, and the area of a rectangle is just base times height. Base times height. Okay? So let's find that base and height. The height's the easy one. This function goes from y equals 0, which would just be on the ground here on the x-axis, and it goes up to 0.5. So it's going up 0.5 units. That's its height. Okay, the base of the shaded region, we're only interested in the shaded region here, that's going to be the range, how far we are from negative 1.9 to negative 0.1. We want the distance there. How long is that? So to calculate how far two numbers are apart, you take the bigger number, which in this case is negative 0.1. It's always the number further to the right. That's the bigger number. And I'm going to subtract the smaller number. Okay? Make sure you pay attention to your signs. It's minus negative 1.9. You got a double negative there because the number's all negative itself. So you could throw that into a calculator, or it's simple enough that you could just calculate it in your head. That's going to be 1.8. So that's our base, 1.8, and our height is 0.5. So I'm going to multiply those together to get my probability. So 1.8 times 0.5. That gives me 0.9. Which means in this case, for whatever the experiment this represents, there is a 90% chance that the output, the outcome, is smaller than negative 0.1. Okay? Let's go to the next one. Let's calculate the probability that x is bigger than negative 0.1. So there's a couple ways to do this. Probability that x is bigger than negative 0.1. So for this one, notice we're interested in the same value here, negative 0.1. So we still care about this guy here. But now we like the values that are bigger than negative 0.1. Okay? So we take that negative 0.1, bigger is in this direction. So I'm going to shade that part that's underneath the probability density function. Okay? So we again want to find the area, but we want to find the area of the region that corresponds to this interval, to the part that's bigger than negative 0.1. So in this case, this green shaded rectangle. So it's still a rectangle. We're still going to calculate it with base times height. Okay. Now the height is the same. It's a rectangle all the way over, right? It just stays the same height all the way over. Let's see if I can get the right height. All the way over, right? The base, though, is going to be different. This rectangle is a little bit different. So to calculate the base for this green rectangle, I again take the bigger number and I subtract the smaller number. And you could either throw that into a calculator or compute it in your head. That's 0.2. Okay? So the base is 0.2. The height is still 0.5. It's the same all the way across. If I throw that into my calculator, 0.2 times 0.5, I get 0.1. Okay, which means there's a 10% chance for when I perform this experiment that the outcome would be bigger than negative 0.1, right? Notice that together, these two, if I add these two together, 0.9 plus 0.1, that gives me 1, right? That's 100%. 0.9 plus 0.1 is 1 or 100%. That makes sense because if I look at this, the triangle or the rectangle on the left and the rectangle on the right together, they fill up the area that's underneath that line, right? Together they fill up that whole space underneath that line. And I know that that whole area underneath my probability density function, that is equal to 1. So together they should be equal to 1. So that means another way I could have calculated this, if I had made that observation first, I could have known that everything bigger than negative 0.1 plus everything, or I'm sorry, everything smaller than negative 0.1 plus everything bigger than negative 0.1, that represents everything that could happen, right? You're either going to be smaller or you're going to be bigger. And so that's got to equal 1. It's got to equal 100%. It fills that whole space. And so if I move this guy over, subtract both sides, one dotted line there, there we go. I find that the probability that x is bigger than negative 0.1 is just 1 minus the probability that x is smaller than negative 0.1. And I already calculated this in step 1. That's 0.9. So this is going to be 1 minus 0.9 or 0.1. So that's another way to calculate the same probability. We just had to recognize that these two together fill the whole space. And so when you add them together, the probability has to be 1. Okay? We still have one more probability to calculate. We need to calculate the probability that the outcomes between negative 1.7 and negative 0.3. So let's get a fresh, oh, maybe not. There we go, a fresh graph. And let's find that probability. Let me just write that down so we don't forget it. Probability that the value is between negative 1.7 and negative 0.3. So negative 1.7 less than x less than negative 0.3. Okay? Now again, for these continuous probability density functions, probability is equal to area. So I need to find the area underneath my probability density function that corresponds to this region. So let's find out where that is. So negative 1.7, well, that'll be about there, right? Negative 0.3, that's about there. And I'm interested in the values that are in between those. I'm interested in outcomes that are between negative 1.7 and negative 0.3. So I'm interested in all of this that's in between those numbers. Okay? So if I can find the area of this shape, then I will have the probability that x is between negative 1.7 and negative 0.3. Okay? Hey, it's a rectangle again. We know how to calculate the area of rectangles, base times height. Now the height is still 0.5. It's a rectangle, it's straight, this line straight all the way across, and so that height just stays at 0.5 the whole time. But this guy, this base, that's going to, we need to calculate that. So I take the bigger number, that's negative 0.3, and I subtract the smaller number, that's negative 1.7. Okay? And if you calculate that, you will get 1.4. You could throw it into a calculator if you're not comfortable doing that in your head. So that base is 1.4 times the height, which is 0.5. And let's see what that gives us. 1.4, the base, times the height, which is 0.5. That gives us 0.7. So 0.7, that's this guy here. Oh, and this was 0.1. Let's make sure we fill that in. Which means, for this experiment, represented by this probability density function, if we run this experiment, there is a 70% chance that the outcome will be between negative 1.7 and negative 0.3.